Now that we've covered the basics of research designs and research methods, I want to take a closer look at experiments, quasi-experiments, and non-experimental designs like correlational research in part 3 of this lecture. True experimental research allows us to study cause and effect relationships, although not perfectly. In order for a study to be considered a true experiment, it has to have a number of features. 1, the researcher has to have control over the experimental procedures. 2, participants must be randomly assigned to the conditions. 3, independent variables are manipulated in some way. And 4, dependent variables are measured. Many experiments occur in a laboratory where psychologists have a great deal of control over the environment. Some experiments are conducted in the field, in actual organizations with real employees, where people tend to act more naturally, but where psychologists don't have as much control and therefore cannot be as confident or as certain in their results and their conclusions, generally speaking. IO psychologists in particular might manipulate job satisfaction, organizational commitment in some way, shape, or form, and then measure the impact on job performance or turnover. IO psychologists often refer to the independent variable as the predictor and the dependent variable as the criterion. Here is a visual representation of what a true experiment looks like. The intervention group is at the top. This is the group that receives the treatment. The control group does not receive the treatment. Before the treatment or the intervention, both the intervention group and the control group are measured. Then, only the intervention group receive the unique treatment, and then both groups are measured again. By comparing the pre-test and the post-test, the pre-measure and the post-measure, we can draw conclusions about whether the intervention, the treatment, caused any differences that we find. We may not find differences, but if we do, we can then draw conclusions about cause and effect. If we find differences between the intervention group and the control group, we use statistics to determine whether that difference has any significance, has any meaning. Sometimes groups are different by chance because no two groups are ever going to be exactly the same. So we would expect tiny differences between two groups who are in fact very, very similar. Tiny differences. But at some point, those differences may be so great that now they are not caused by chance. They are caused by something else, by our intervention. If the difference could have occurred less than 5 times out of 100, then the difference is considered to be significant. Less than 5 times out of 100, that's not a lot of times. That's a rare occurrence. So it's probably not occurring by chance. It probably has something to do with what we did, the data that we collected. Of course, this calculation is not absolute. It's only a probability. This is one of the reasons why it is so important for the research community to test hypotheses and theories again and again. Here's another table that compares the advantages and disadvantages of experiments. Take a moment to review it before moving on to the next slide. Quasi-experimental research is similar to experimental research with one significant difference. Participants are not randomly assigned to conditions in quasi-experimental research. In some situations, we can't randomly assign people to two different groups. Imagine you have a training program that you would like to evaluate, and you have a group of people who need to be trained, but they all need to be trained. They cannot be split into two different groups, maybe for budgetary purposes, maybe for logistical purposes. The group needs to be trained together. You can measure their knowledge before the training, take them through the training, and then measure their knowledge after the training. At the same time that you take those two measures, let's say you take the first measure in January and the second measure in December, you could find another group of similar employees who do not need the training and take those same measurements in January and December from that group who did not receive the training. Employees were not randomly assigned to the group that was trained and the group that wasn't trained. Those groups already existed naturally in the organization. As you've probably guessed, quasi-experimental research is not as strong as experimental research for this reason. Non-experimental research is the most common method used by IO psychologists. This is when we measure two or more variables and then use statistics to try to understand the relationship. But with non-experimental research, and really with quasi-experimental research, we can't assess cause and effect. There are features that are missing from these two designs that limit the types of conclusions that we can draw. They're just not as strong as the gold standard, as the experiment. There are different types of non-experimental research. Descriptive research describes the variables, describes the phenomenon. This includes things like observational studies, where we simply observe people doing their jobs. We don't ask them questions. We don't ask them to take a survey. We just observe what they're doing. It can also include surveys and archival studies. With correlational research, we measure two or more variables and then use statistics to assess the relationship between those variables. Let's take a closer look at what is involved in correlational studies. Here's a visual of what a correlational study might look like. As you can see, there's only one group when we use this method. We collect the same information from the same group. Now, we can still collect information at two different points, both before and after an intervention. Sometimes correlational research is even simpler than this. We collect both sets of variables at the same time. For example, we might compare trainees' scores on a cognitive test with their grade in a training program. Each one of the dots in this scatter plot is an individual person's data. We can tell by looking at the graph that people who score 25 on the cognitive test tend to score anywhere between 25 and 50 in the training program. But people who score higher on the cognitive test, say a 75, they tend to do better in the training program and score a 75 in the training program as well. Using statistics, we can calculate what is called a correlation coefficient, which is a statistic, a value, a number that describes the relationship between these two variables, between cognitive test scores and training grades. Correlation coefficients tell us about the strength of the relationship as well as the direction of the relationship. This coefficient can range anywhere from -1 to +1. When the value is closer to 1 or -1, the relationship is said to be strong. When the value is closer to 0, the relationship is weaker. A strong relationship means that those two variables, given most situations, are probably going to be related to one another. When the number is a positive number, above 0, the two variables change in the same direction. When one variable goes up, the other variable goes up. When scores on the cognitive test are high, scores in training also tend to be high. When the value is negative, the change occurs in different directions. When one variable goes up, the other variable goes down. When people score high on the cognitive test, they perform poorly in the training program, which logically doesn't make much sense, but the training program could be a terrible training program in this example. So again, the stronger the relationship, the better the prediction we can make. Here are some more examples of scatter plots, which are the primary way of visualizing correlational data. These statistical analyses that we use involve regression, the regression line that you can see in each one of these graphics. The graphic on the left has a correlation coefficient of 0. That is what data looks like when there is no relationship between the two variables. The graphic in the middle represents what the data would look like if the correlation coefficient was positive 0.5. As the value of one variable increases, so does the value of the other variable. In the graphic on the right, we have a negative relationship with a correlation coefficient of negative 0.5. As the value of one variable goes up, the value of the other variable goes down. That is what the negative sign represents. Much of the time, we're looking at linear relationships where the regression line is straight. In some situations, the relationship may be curvilinear, as it is with arousal, stimulation, and job performance. So what do I mean by that? Job performance is highest when people are moderately stimulated. If there is too much stimulation, if there's too much going on, too much noise, too much stress, too much work, it's difficult for people to do their best. If there isn't enough stimulation, if people are bored, they don't have much to do, there's no challenge to the work that they're doing, performance is also likely to be low. Now, this isn't the case for everyone in every situation in every organization, but generally speaking, the relationship between these two variables is curvilinear. Sometimes IO psychologists are interested in the relationship between a collection of variables called the predictors and a single criterion. For example, in order to predict which job applicants will be the best performers so that we can hire them, in order to do that, we might measure their KSAOs, their knowledge, skills, abilities, and other characteristics, as well as their personality, their experience, and their level of motivation. We can combine those 4 variables in order to predict who will have the highest job performance in the future. The coefficient that we get is called a multiple correlation coefficient because there are multiple predictors that we're attempting to match with the criterion. Here are some of the advantages and disadvantages of correlational research. Please take a moment to review them. I will draw your attention to one of the disadvantages, and that is to simply remind you that correlational research cannot assess causation. This is because there may be other explanations for the relationships, other explanations that we didn't test, that we didn't measure. Just because 2 things are related doesn't mean that one causes the other. There could be a third variable that is actually in charge of, or that drives the changes, drives the relationship between two different variables. For example, the amount of aggressive television programming that a child watches has a positive relationship with the extent to which they express aggressive tendencies. So there's a positive relationship between those two variables. What could be really going on is that there's this third variable, family troubles, that leads children to watch aggressive television and behave aggressively. But we wouldn't know that because we didn't conduct an experiment, we didn't gather information about family troubles, so we missed that part of the phenomenon of reality. That is the greatest weakness of correlational studies. But they tend to be the simplest, least time-consuming, most convenient way of studying work behavior.